For today, here's the plan. Yesterday, you watched a video that I had made that helped study for the first part of the cumulative. I'm going to review a few of those things with you right now. And then we're going to, I think the next logical thing is talk over the test. I'll hand back the other test. Then we'll talk about common mistakes that you made. I can't put that on the video because, you know, like people haven't even taken the test yet, so I can't publish on YouTube, you know, what you did wrong on the test because a lot of people haven't taken it. But then we will spend the last part of this hour talking about the cumulative, but I don't feel like you'll be ready to just take the cumulative tomorrow. Okay, so we'll spend a whole nother day tomorrow reviewing for the cumulative, all right? And that puts you in having plenty of chance to fix any mistakes that you made on the last test and relearn that stuff tomorrow, which would be Wednesday, and then the cumulative will be Thursday, all right? So me being gone did cause us an extra day here, but that should give you plenty of time to get it all fixed and ready for the cumulative on Thursday. All right, so here's a little review of that higher degree polys test. Do you remember synthetic? All right, so let's say I had synthetic division going on with this. My question is, do you remember how to start it even? Well, it was adding down, so this one we just dropped it. I kind of made fun of it and said drop it like a tot. Then you multiply this. Then you add straight down, which was 0. Then you multiply again. 2 times 0 is 0. And then you add it straight down and you get 3. Now, that's kind of weird. Don't they normally end with a 0? Well, only if it works. This one didn't work because there's a remainder of 3. Does that ring a bell? All right, so I'm going to give you another problem, and you have to set up the synthetic for it. Now, you have to know long division and synthetic. So why don't we actually start with long division on this one? And then we'll do synthetic, where you put the 1 here. Remember, it's what makes this equal 0. It's not the copy of what's there. It's the root of what's there. So we'll do synthetic later, but let's start with long division. This test that you have on the cumulative now was one of your harder tests. We had to remember so many things on this unit. There was how do you figure out what the possible roots are? That was a rational root theorem. There was factoring really big long things. And then there was long division like this. If you remember it right, you'll remember to start with an x right there. X times the x makes x squared. X times the -1 makes negative x. You draw a line. Here was the most commonly forgotten step. Opposite, opposite. Then the reason I know that x was the right thing to put up on the top here is because these match each other exactly. So when I do the opposite deal, x squared minus the x squared will give me 0. Like, there's nothing left there. So then I just put these two together. Notice I didn't say add or subtract. Combine those two, and I get 5x. What's the next step? Yes? Bring down the -5. Perfect. Then we got to figure out what goes on top. I need to put something up there so that when I multiply it, I get that. So then it's like, oh, it must be a 5 then. A positive 5. A really common mistake right there is to think it's -5 because the kid's already trying to subtract them. You want to match it exactly. X times 5 is 5x. See, I matched it exactly. Then, when I make the signs go to the opposites, opposite, opposite. Everything cancels. I got a 0 remainder. Yay. Does this ring a bell? Remember doing this? Okay. So there was much harder problems than this, though. And that's why we did synthetic. Just a quick reminder of how the synthetic would have went. This would have been a 1, and this would have been a 1 and a 4 and a -5. Everybody just do the synthetic real quick on that. Make sure you remember how synthetic looks, works. Because if you don't have synthetic down, you're definitely going to bomb this cumulative. So let's make sure you get it down. Again, I'm taking it slow. We have a whole nother review day tomorrow. You'll have a chance to ask me questions tomorrow. I appreciate your patience with me today. I am kind of suffering. I'm still kind of getting over being sick, and now my back is out. Like, I got this, like, oh, my lower back is killing me. So I think it's from twisting and coughing a lot. Threw my back out. But I'll survive. But be patient with me. So then I multiply this times this. 1 times 1 is 1, and then I add them, and I get 5, and I multiply them, and I get 5 times 1 is 5, and then I add them, and I get 0. That's where I want the 0, right there. I wall it off, and I call that the remainder. Do you remember that deal where this comes down, and it makes x plus 1? You know? No, oh, minus, thank you. I went and looked up there to make sure I didn't screw it up, and I had. It's the opposite of this number because it's the relationship between the root and the factor, or the 0. This is called the 0. It's what makes this 0. And then this other part is you put an x here, and you get x plus 5. All right, that was like a baby one. Super easy factoring, really no big deal. But I needed to show you on an easy one. So now let's say I did this, and I'm going to kind of cheat, and I'm going to make that last number be just right here, so that this thing has a remainder of 0. So go ahead and act like we're doing synthetic here. See, I kind of cheated. I put a -12 at the end now. It's going to work. I know because the 6 times the -2 makes -12. And that gives me a remainder of 0. Can you interpret this answer? Like, what does that mean? And what does all that mean? Pause for a second while you give that a try. Okay, this translates to x plus 2, because that's the 0 for this factor. And then this is the constant, so we just write a positive 6 here. This is the x's, and this is the x squareds, which means x squared minus 2x plus 6. Now, let's see if you passed the test. Did any of you even look to see if that would factor? That was smart, because if you forget on the test, the directions are going to say it. But I got to remind you, must be factored all the way. Factor it completely would be another way to say that. See, if you don't factor this the rest of the way, then you lose. So hopefully you thought about that. Now, in this case, I actually don't think it factors. Okay, but if it had, you would for sure have needed to do that. All right, next thing that was on that old test was like boing, and then it cuts through there. Let's say this is at 8. Let's say this is at -3. And then it seems like you should be able to write an equation for that. Can you write me an equation for that? It's got a double root. It's got a single root. You should know what that means. Did you remember the negative? What negative? It's going down on the right. That means there's a negative in front of your equation. Be honest. How many of you actually remembered that? It's like 5 of you. All right. So easy to forget, isn't it? Now this part needs a x plus 3, and it's a bouncing motion, so that means squared. Then there's that x minus 8. And there's your equation. Now, I could have made it more complicated where you had to like figure out what the stretch factor was. I did not. And so therefore, because I didn't put what the y-intercept was, it would have been really hard for you to figure out a stretch factor. So I am kind of intentionally ignoring that there could be a stretch factor there. Yes?
Do you always want us to put the biggest term in front?
Nope. These two could be reversed. It's just that wherever this is, it has to be squared. Okay, one more like that, because a fair number of you lost because you forgot something. That's 5, that's negative 6, and that's at 8. You can write an equation for that. I'll pause for a second while you give it a try. When you're done, compare with the kid next to you. Okay, let's see how you did. Y equals, once again, going down on the right. If you snoozed again, then I don't know. But I also have 3 parentheses. This one, negative 6, that means x plus 6. And then since it's bouncing there, squared. This one's a 5, so I go x minus 5, also bouncing there. And the last one is an 8, x minus 8, not bouncing there. Now, one thing that could burn you is that could have theoretically been an x to the 3rd. Now, how would you ever know? The ones that are cubics, I'm going to make you one right now, they will be kind of pronounced where it's an inflection point. So it has to be like changing over in this zone between rising the whole time, but changes from rising at a slowing rate to rising at a fast rate. And that's called an inflection point. That'll be to the 3rd. If you're having trouble looking at a graph and going, is that supposed to be to the 3rd or is that supposed to be to the 1st? I will answer you on a test by saying, I can tell that that's an inflection point. And then you'd have to go, oh, I guess it is to the 3rd. All right. Would you please write me the equation for this one, knowing that right there is an inflection point right at the origin? What would be the equation for that then? Now, some people are probably just struggling with what to put in there. Like, and then I never told you what that number was, so I'll just say that that's a 9. If it isn't clear, that's a 0. And so some kids put x plus 0 in here, or x minus 0, but I think it's best to just say x. And then since it's snaking through there, I would also say passing through is okay. I put it to the third. That's a special kind of power to the third. And then this other one would be x minus 9, and it's not bouncing or anything, so we can assume it's to the 1. If you wanted to ask, like, Mr. Server, is that an inflection point? I would say, no, it's not an inflection point. It's just passing through, and therefore 1. If it had been an inflection point, then you'd say it was to the third. Question?
Is there a negative? There's a negative.
No, you caught me. Yes, it's going down on the right, and I forgot the negative this time. Thank you. Okay. So there's a little review of the higher degree polynomials test. Oh, one more thing. You can totally see this on the test. What's the lead term? Act like you multiplied it all the way out, and then you'd know what the lead term was. What's the lead coefficient? It's different. It's a subset of the lead term. And then what's the degree of this one? Okay, the lead term, you take this times this to the power of that. So don't forget that squared. So it's 2x to the third. Raise your hand if you had that one right. Okay, that's correct. Now, if you thought it was just the lead number, that would have been a 2. That's the coefficient is the number on that lead term. And then what degree is it? It's degree 3. Do you want another practice of one like that? I'm seeing lots of nods. Okay, let's do another one like that. Be careful with the squared this time. I moved it. What's the lead term? What's the lead coefficient? And what's the degree this time? Careful, I moved the squared. Okay, notice this gets, here I'm going to do a different color. This gets squared, and the 2 gets squared also, not just the x, so it's 4x, and it would be squared, but there's an extra one here, 4x to the third. The lead coefficient is the 4 then. And the degree, 3. It's the power. All right. Then, what's happening on the right? Up or down? That's all you got to know. What's happening on the left? It's just up or down. Niven, what do you think it's doing on the right? You are correct, because the number in front here, the lead coefficient, is positive. So it's going up on the right. On the left, Amelia, what do you think it's doing on the left then?
Going down.
Down, because why?
Because the degree is odd.
Because that's odd, so... You were saying it right, I'm just repeating it for the video. Because the degree is odd, what does that mean then?
Because the odds
So that does the opposite. This one was up, then if it's the degree is odd, it'll do the opposite thing on the other side. All right, cool. So now let's do a little review of the other part of the test called rational functions. I feel fortunate that we have time to take 2 days to review for this cumulative. So this isn't our only review of rational functions, but I'll review the things that got marked wrong the most on the test. Stuff like that got marked wrong a lot. It's because kids had a hard time finding a common denominator. The technique I have taught you is to multiply by the other denominator. But if even people remembered that, they still often ended up messing it up because maybe they didn't cancel stuff at the end, or maybe they didn't simplify it right. So why don't you just give this one a try? After you've multiplied by the other denominator, it's really tempting to think you need to multiply that denominator out. But then at the end, after you had multiplied it out, you would go, gee, I wonder if I should factor it. And of course, the answer is if you can factor it, you should. So bottom line, don't even multiply it out. It's already factored. Why would you want to mess that up? Leave it factored. And on the top, I have to distribute this. 5x plus 20, and a lot of times on your test there might be a minus right there, but there isn't this time. X squared plus x. And if I simplify that all down, I'd have x squared plus 6x plus 20 over x times x plus 4. Did you even think about factoring that? If you didn't even think about factoring it, you lose. If you thought about factoring it and realized it actually doesn't factor, then you win, and you just leave it like that. Okay, next major topic that was critical, horizontal and vertical asymptotes. I'm going to give you a different kind of problem for that. That's already pre-factored just to save us time. I can tell you the horizontal and vertical asymptotes of this. The horizontals is the one where you think, I wonder if there's a dotted line like this that it will trend closer to as I stick in really big values of x. The vertical is whatever makes the bottom 0. And in this case, there's clearly not a hole, so I won't even bother you with that, but there will be on a different problem. The dice say I should call on Catherine von Smith. How do I do the horizontal again? It's like this dotted red line. You try to go way to the right to see whether it's trending there. That's not what you're doing to try to figure out the horizontal. I think what you're doing is figuring out the vertical asymptote. Okay. All right, so let's talk it through. Horizontal, that's the one where you're trying to find a dotted line like this, and that's the one where you use the 1,000 idea. Okay, so we're going to put in 1,000 here and here, and you tell me, how do I do that 1,000 thing again? We're trying to see where it trends in the long run. So we put in a big number like 1,000. Would you agree it's pretty much 1,000 over 1,000? Which is pretty much what? 1. Yep. The vertical is the thing you were talking about that makes the bottom 0. What makes the bottom 0 is 8. X equals 8 is the vertical asymptote. And then when you were starting to talk about sticking it into the equation, that's what you do if you were trying to find a hole. We'll have one of those in a moment. Any questions on this one? All right, here's a more complicated horizontal. See if you can handle this. Find the horizontal, just the horizontal on this one. And if you get confused after you stuck in 1,000, try sticking in 1,000,000. If you're still coming up with about the same answer, well, then that's the answer. If every time you put in a huge number, the answer changes and gets even bigger, then that means there isn't an asymptote. All right, so I'm putting in my 1,000. Hakan, talk me through this.
Well, the 1,000 times 5 is 5,000 over 1,000.
So it's about 5,000 over 1,000. Would you agree that these thousands could cancel?
Yeah, and then
What's the answer?
pretty much 5. Or
Pretty much 5. And if I had put in 1,000,000, the millions would have canceled. And it would be pretty much 5. So the answer on that one is 5. Remember, if you can cancel out those thousands, cancel them. Otherwise, you're trying to go, what's 5,000 divided by 1,000? And it's more complicated. You just cancel the thousands and you get 5. All right. Now for the ones that generally represent the most marked wrong questions on the test. What if you have something like this? One second here. You have a picture? Is that what your deal was?
Yeah.
Okay, go ahead. My question on this one is, first of all, of course, if you can factor it, you should. And then, is there a vertical asymptote? Is there a hole? Maybe you should find that first if there is. And then, is there a horizontal asymptote? But remember, get it factored first. I think some of you are way overthinking the factoring. All you had to do is factor out an x on the top, and you get an x plus 5. Because they both have an x in it, so that's the GCF. And on the bottom, the same thing, except you get an x minus 5 on the bottom. This happily cancels out, which creates a what? A hole. At what? 0. Because that's what would make this 0, is if you put in 0. 0 comma what? Well, I like to simplify my answer at the end. I like to say y equals x plus 5 over x minus 5. That's my resulting function. That's the function after stuff canceled. That's where you put the 0 of the whole is back in here. And I hope you quickly realize that's 5 over negative 5, which makes negative 1. Who had a negative 1 before I said it? Awesome. The vertical asymptote, time to put that in here. The vertical is what makes the bottom 0, which is 5. And the horizontal is the 1,000 idea. If we go way to the right by putting an x as 1,000, we see that the adding 5 and the subtracting 5 really don't matter. It's just 1,000 over 1,000, which is pretty much 1. Raise your hand if you had that one right. Cool. Then the only other thing you had to do on the test was graph those. So make a sketch where the x asymptote is and the y asymptote, and make a hole there. And then you find a few points around the x asymptote. That's 1. That's 5. The hole's at 0, -1, which is like there-ish. Now I need a few more points. Well, since x equals 5 was the asymptote, then you should have tested 4 and 6. Stick in 4. And you get 9 over -1, which is -9. And when you put in 6, you get 11 over 1, which is 11. So 4 -9 is like way down here. Oh, that makes sense. Gets closer and closer to the asymptote. Notice I didn't forget the hole. A ton of you guys are gonna go, oh crap. I graphed it, but I forgot to put the holes in on your test. 611. If I go to 611, that's gonna be basically way up here. Let me erase this line out of here. Make room for my... It's like way up there. I really only need 1 point to get the idea that it's gonna go like that. My one important point being like right there-ish. Okay. There's the big picture. That's everything that's on the cumulative. We'll have one more day to review for it because we went a little faster earlier. Now we got more time. And today's your day to do corrections. Now, a lot of you guys did fine. You've probably already looked at your scores. But if you didn't do fine, then when I give it back to you, I'm going to remind you that scratch paper is right here. You have to do corrections. If you want this to count as a retake, corrections are required. So this, right next to the stapler, there's a pile of blank paper right here. If you're gonna do corrections, you'll grab one of those and start fixing your mistakes on that page. So, this is the part right here. That's all I have for the video for today. I'm gonna hand those tests back and let you start your corrections.